Coordination compounds are molecules or ions that consist of a central metal atom or ions surrounded by molecules or ions known as ligands. These ligands donate electron pairs to the metal through coordinate covalent bonds. The central metal ion, along with its attached ligands, is called the coordination sphere, which is usually enclosed in brackets when writing chemical formulas. The central metal ion in coordination compounds is usually a transition metal with a specific oxidation state, such as Fe2+ or CO3+. This oxidation state is key for naming and understanding the compound's properties. Ligands are atoms, ions, or molecules that donate electron pairs to the metal. They can be neutral, like H2O or NH3, or anionic, like Cl2+. Ligands are classified as monodentate, binding through one donor atom, for example NH3 and Cl-, bidentate, binding through two donor atom or polydentate, with multiple donor atoms binding simultaneously, for example EDTA, which is ethylene diamine. The coordination number is the count of ligand donor atoms bonded to the metal, influencing the complex geometry. Common coordination number include 2, which is linear, for example AgNH3 2-, 4, tetrahedral or square planar, for example NiCO4 or PtCl4 2-, and 6, octahedral, for example COH2 or 6-2+.
Now, let's go through the naming rules and priorities for coordination compounds. First, we always name the ligands before the central metal. For ligands, anionic ones end with O. For example, chloride becomes chloro. Neutral ligands use their common names like amine for ammonia and aqua for water. When we have more than one of the same ligand, we use prefixes such as di, tri, tetra. For example, two ammonia ligands would be called diamine. It's important to list the ligands in alphabetical order, but remember to ignore these prefixes when alphabetizing. After naming all the ligands, we state the name of the central metal. If the complex is an ion, we also indicate the oxidation state of the metal in Roman numerals in brackets. For example, the complex shown above is named diamine silver 1 ion. Here, diamine refers to the two ammonia ligands, silver is the metal, and 1 is the oxidation state.
Alright, here's a cool and more advanced complex. Let's name it. So we have two ligands here. En is short for ethylene-diamine. It's a bidentate ligand, so which means it attached at 2 points. And then we have C2O4 2- is the oxide ion, also a bidentate ligand. So both ligands wrap around the metal at multiple points. Now we name the ligands in alphabetical order, ignoring the prefix. So E comes first before O. So we will get bis ethylene diamine oxalato. We use bis for ethylene diamine because it already has a number inside its name instead of just di. Let's name the metal and find its charge. The metal right here being chromium, and the complex has a positive 1 charge overall. So let's calculate the oxidation state of chromium. So N is neutral, so 0. Oxalate is -2, and the overcharge being positive 1. So Cr plus -2 equals to +1. At the end, we will get chromium equals to +3. So we call it as chromium 3. So finally, the full IUPAC name of this complex is bis ethylene diamine oxalato chromium 3 ion.